So to get this warm-up now started, you officially have the identities you chose. So now you're taking a moment to fill in what you know and solve for what you don't. So you want to take a few moments and check over your warm-up. A lot of algebra leaking into this particular lesson. Go ahead and read this example 1 together. Again, we're asked to verify that each of these following things are true. So for here in part A, we have secant theta times cotangent theta. It should say equals cosecant theta. So I always like to, like I said, kind of begin with the end in mind. So quite often you're going to see me sort of just take a look at the right side of the equal sign and sort of reverse my way backwards. And then I always think it's a nice little hack to turn things back into, I call them their original functions. Remember the first functions we talked about were SOHCAHTOA, sine, cosine, and tangent? So I always like to take them back to their basics. So when I look at this cosecant, in the back of my mind, you can jot this down. I'm thinking about its reciprocal identity. It is just 1 over sine. So then it becomes a task of, well, how can I get secant theta and cotangent theta to also be rewritten in terms of sine and cosine? So when I think about secant theta, or secant t, potato, potato, make it a theta or make it a t, either or. It's all good. We know that's an angle measure. I think secant is, I mean, you can correct me if I'm wrong, but I think it's 1 over cosine. I'm just going to make it a theta. All right, here comes a question for you, my very intelligent trigonometry students. Cotangent theta, if I wanted to rewrite that in terms of sine and cosine, how would I do that? So we're rewriting cotangent in terms of sine and cosine. How would I do that? Go ahead, Parker. So that's true, but I wanted it in terms of sine and cosine. So you're looking at the quotient identity.
Oh, cosine over sine.
Yes. Oops, I meant to grab purple there, sorry. So the quotient identity is the identity that takes it back to sine and cosine. When I multiply fractions, I am allowed to cross cancel. So do you see what's going to cross cancel? Those cosines are a goner. And then we multiply straight across. So if I multiply straight across the top and straight across the bottom, I have 1 times 1, technically, and that's just 1. And then across the bottom, I have 1 times sine. And that's 1 over sine. Which is, oh my goodness, do you see this? Look, this and this, they are the same. That is magical, which means that this is equal to my cosecant theta. So I'm done. I worked all the way from the left side and I got to the right side. And I'm a pretty happy camper about that. All right, that was fun. Let's do it again. So again, my hack is just to kind of take everything in the problem and sort of take it back to sine and cosine. Again, it doesn't work all of the time, but it works a lot of the time. So what I'm trying to tell you here is that for this one, sine is fine. You know, if it bothers you, you could rewrite it as sine of theta or sine of t over 1. And then again, if I want to take things back to sine and cosine, for cotangent, I would just use my quotient identity for cotangent. And that guy just says, hey, you know, we're cosine t over sine t. You see the magic that happens there? So when we multiply fractions, we're allowed to cross cancel. So what I end up getting is cosine of theta, or t, over 1, which is just the cosine of theta. And I'm pretty happy because I worked my way from the left side to the right side of the equal sign. I proved that that is a true statement. All right, another one really similar to one on your homework. Tangent theta times cotangent theta equals 1. We have options, kids. So I'm going to go ahead and throw this out to you. Ashley is taking my advice from earlier. I could see it, bird's eye view here. She's doing a good job. She's taking it back to sine and cosine. You don't have to, though, but you can. It totally works. So I'm going to just throw out a couple of options just to remind you there's more than one right way to do this. So bird's eye view, I can see, you know, you're using the quotient identity. Tangent is sine over cosine. That is legit, yo. I like it. Cotangent would be cosine over sine. These guys cross cancel. These guys cross cancel. And whenever we put slashes through things, you just end up with like 1 over 1, which is 1. So we're pretty happy about that. So that's great. Keep in mind, you didn't have to turn them into your sine and cosine. So this is us kind of setting up for, you know, other options. So let me just, I'm going to draw a little squiggle here. We'll call this like option number 1 because y'all went for it. That's pretty good. Option number 2, remember it's this idea of multiplying things together to get our multiplicative identity. And in order for that to be true, these two things, tangent and cotangent, have to be multiplicative inverses of each other. In other words, they have to be reciprocals. So what I can do is use my reciprocal identity to verify this as well. So for instance, we can leave tangent the way it is. And then I can rewrite cotangent as 1 over tangent. These things cross cancel. Again, you're still left with 1 over 1, and that's 1. So just remember that, yes, it is super helpful in a lot of instances to just kind of take everything back to sine and cosine, but you don't have to. You could also use your other identities. As long as you're using identities, you are golden. Part B. I don't see any 1s in this one, so I'm not thinking reciprocals are going to be great. Also, you know, if I see 1, I start to think about the Pythagorean identities a little bit because they all had 1 in it. But no 1s here, so yeah, I'm going to go ahead and take, since I see cosine and sine also in here, tangent, I'm going to go ahead and use my quotient identity on that guy. So tangent, you might recall, is just sine. This is alpha. Kind of looks like a little fish. But the Greek letters we just use for angle measures. You'll see like alpha, beta, of course theta hanging out there. So this is going to be sine alpha over cosine alpha. And then cosine, I'm going to leave that. That's cosine alpha over 1. And then look at that, kids. Oh my gosh, so cool. The cosines are going to cross cancel. So what you're left with is basically sine alpha over 1. Which, hey, look at that. That's just sine alpha. So I got back to the other side of the equal sign, which makes me pretty happy. Good job, people. It wouldn't be a day spent on identities if I didn't bring in the grand poobah of our identities. So yeah, you can use your Pythagorean identities in their factored form to kind of work things out as well. When I see squared, like what's grabbing my attention right now, and I don't know if you know. See this? Oh my goodness. That is your giveaway. Like you are doing something with your Pythagorean identities. A squared over there, oh man, we gotta do that. So when I look at this, quite often, you know, everything's already written in terms of sine and cosine. You're like, okay, well, I can't use that tip anymore, Mrs. Lucas. Like, what am I even gonna do? So if that's the case, I usually just let the left side be the boss. And this is why we had that algebra boot camp a little bit ago. When I see parentheses times parentheses like that, well, I almost couldn't say it. When I see parentheses times parentheses or a quantity times a quantity, I don't know about you, but I think about foiling. So that's what I'm going to go ahead and do. I'm going to do my first, outers, inners last. So if I multiply my first together, I'm taking 1 times 1. 1 times 1 is 1. My outers, in this case, would be 1. I don't like the color of this arrow, sorry. So 1 times negative cosine theta. So 1 times negative cosine theta is just negative cosine theta. Then I'm going to go ahead and do my inners, because I stands for inners. So cosine times 1, that's just positive cosine theta. And then my last is positive cosine times negative cosine. Positive cosine times negative cosine would give me negative cosine squared theta. So simplifying this line, what I would observe is that my outers and inners cancel. Negative cosine plus positive cosine, those are additive inverses, they would make 0. So what I have left over is 1 minus cosine squared theta. Well, now in my head, I'm like, well, like, what is that? Like, what am I allowed to say about that? So here's me thinking. I'm like, okay, well, sorry, I'm going to refer to myself in kind of a third person here, but I did say, you know, we want to think about the grand poobah. Sine squared theta plus cosine squared theta equals 1. And what ends up happening there is, if I just take a second to subtract cosine squared theta from both sides of the equal sign, balance that, I get sine squared theta equals 1 minus cosine squared theta. So I just took a second and I used my subtraction property of equality and I took cosine squared theta away from both sides. And what I observed is that I could get sine squared theta by itself. And more importantly, what did it end up being equal to? 1 minus cosine squared theta. So it's the same thing. A little color coordinating there. So what I learned is that this is just equal to sine squared theta because, and I'll abbreviate because, sine squared theta plus cosine squared theta equals 1. So that's how you round these out. it is this because we have this glorious identity to help us out. So you just kind of say it is because it is when you're done. Seems a little silly, but that's how that goes. This does mark the end of our 1-3 notes. It's not a bad opportunity, not a bad moment to take some time right now, flip through your 1-3 notes.